I would like to share some of my experience from my school days. My parents were working and my sister, I have an younger sister. So usually on the working days from morning 8 to 9, it will be the most hectic hours. So we'll be busy with running around to get things done. So it was my duty and my father's duty to iron all the clothes. A pile of clothes will be there in the table and we'll be in the rush. So I will just switch on and we had to wait for some of the time to get it done. Like, oh, it's not good. We have to wait. And then while ironing itself, it will take some time. Like my mother will come and bring the breakfast, or I have to pack my bag and everything. So I may keep the iron box there itself. So it's not safe, and it may fall to the clothes and it may burn. So that's why my sister is not doing this one, because she ruins some more skills. So what's the solution for this thing? So we have two solutions. One, do the ironing on Sunday, and the second one is that to get a smart iron box. So what is smart iron box? Okay, so I have a smart iron box. So I will switch on the power supply, but it will not heat on the, like, whenever, even though it is switched on, it will not heat. But that's not good. So what should be done? Like if I am taking the iron box in my hand, at the moment itself, like within a fraction of a second, it will heat to the set temperature. So if it is, if you want 120 degrees Celsius, whenever I am taking it, it will go to 120 degrees Celsius. I can iron it, put it back, then it will go to the sleep mode. Like it will not take any energy. So how can it be possible? I will explain the next slide. So whenever I am using it, like whenever I am holding it, it will consume only energy at that time. So there are some, like it will take only 50 to 60% of the time the energy will be consumed. So it is somewhat efficient and safe, and we can actually adjust the temperature in the handle itself, and a lot of cool features are there. So how to get it done? We are normally using the conduction heating principle to heat the iron bending. Here we are using induction heating. So to transfer heat from one point to the next point using a conduction principle, it will take tens of seconds. Here it will take only fractions of seconds. We are using it in the industrial area to heat the magnetic materials. So if there is an iron piece, you can have a coil, and if you are passing a high frequency signal to that thing, so it will come to red hot heat within a fractions of seconds. So the same principle we are using here. So to generate this high frequency voltage, we are using resonant converter, which is actually a power electronic converter with inductor and capacitor, which will be oscillating energy between each other. So depending upon the frequency and the voltage, we can actually heat the surface to a specific temperature. Okay, so the next thing is the power factor correction. In India, so if we are using induction cooktops, most of the things like premium or prestige or any Bajaj and everything, everything I tested in my lab itself. So here, whenever we are observing the waveform, it's not pure sinusoidal. It's actually some harmonics are there. So we have to stick to the things like power factor correction has to be done. So with all these features, this induction heating can be used for our smart iron box. So what are things we have to do is that our iron plate is there, we have to get it heat to a specific temperature. For that we need a high frequency field, magnetic field. And this will be given by this coil, which will be separated by a high frequency AC signal. So the coil, the shape of the coil which will be spiral, but not in circular fashion, it will be triangular fashion. I have made this thing and did the 3D printing of this former and everything, and first prototype is ready, like the proof of concept is ready, not the prototype. And after finishing the epic or something, like in the leisure time, I would like to do it further. And this resonant converter I have modified and I have made one of mine of circuit itself. And this rectifier will be coming with the power factor correction itself. And it will be consuming only like 500 watt to 750 watt, and you can actually purchase it for less than 3,000 rupees with steam and everything, and it will be much better than the available market in the market. So I have 80 seconds more. So this I would like to thank Ram Kumar, who helped me to build the proof of concept, that circuit and everything. And thank you for the opportunity. Thank you.